In this video, we are going to discuss about the what is a linear regression, and then we will understand the maths behind it, and also we are going to see how can we code it from the scratch and as well as using the sklearn library. So let's get started. So linear regression is a ML algorithm that predicts output by fitting best line through the data points. So let's see how we actually do it. So let's say this is our data set. From one side there is a study hours and other side there is a scores. So how much study a student does to and how much it scores. So that this is our data set. Now we want to predict for the other student how much they will score if this amount of study time. So for that we have to predict a line or the plot a line which goes through data points and which minimizes the distance between the line and the average value of the points. So that means the distance between the point and the line should be minimum average distance. So we will start with the y equals to the mx plus c. That this is the simple formula to plotting a line, and m and c value here, it is a random value. So we will start with the random value. We can choose any value here for the m and the c. X will be given there because it is a feature. So we want to predict like for 5 value we want to predict what should be the value score of that. So for that x is the 5 and m and c we will assume anything randomly. So first line will be our random line. So this is the line, let's say this is the line, random line here. Next we are going to get the distance from it. So we actually have the value now. We are in the training period, so we are having the actual value. This is the that is true value. So we are having the true values. So we will calculate that distance, and that distance we will calculate and also do the square. Why? Because this is called a squared error. Because what happens, sometimes we get the distance and this distance be let's say negative. So what happens, that will that shouldn't be not be there, no? So for that we do the square of that, and then we do the mean. That means we get the average of that distance. So average distance of all points, that is by doing the square also. Now this will be our distance that give the loss. L means loss. What was the actual loss? Because we are having the actual truth, so we are just calculating the actual value and the predicted value. What is the mainly loss. After that we are going to have the gradient. What is a gradient? In which direction should m or the c should move to get the lower loss. For that we get we take the derivative of this value. So we take the derivative of the loss to actually get the value where the value of the m and the c will be lower. So for that we do the this derivative, and so dl upon dm, that will be against the dm, and second derivative will be against the b value or the c value. We also say it c. So this against the c, and the it should be c here. We also say it b also, so don't be confused here. Next is next what happens, we get the this that gradient. Now we are going to change the value of w and the b here. Why? Because let's say we have calculated the b value here. Now after that we are going to change the b. B is also a c, so don't be confused there. So b value should be minimized. So we want less and less loss. So we want to move from higher loss to lower loss. So we will do the minus of the w and the b. So we will slightly change the w and the b. Okay, after that we are also multiplying with the lr. LR is nothing but a learning rate. So this defines how much it should move. Let's say we get the derivative like this, so this is very high, like this is the loss, and if the value will be higher, then we what happens, the it slope it will move faster. So sometimes what happens, let's say this there is a shallow difference, that is gradient is very shallow, so it can jump through it, and it does not never finds the actual lowest loss. So what we want, we multiply with the learning rate, so how much speed should be there to changing the W and the B value. Now next, this is like this is how line will move. So let's say this is not actually the like truth. So first of all, we have already changed the value of W and the B. Now we are going to for the next epoch. This is called the next epoch, or next time we also go through that same steps. So this is next step. Now line have been changed slightly. Now next step. Now line is almost perfect. So this is the way we do same step again till the we don't get the perfect line of that, and we also not reach the epoch time. So after this, let's say we get the certain value of M or certain value of C, that was also B, so don't be confused there, B or C. Sometimes we say B or C, this is simply a constant. Then these are also called the weights. Now we are on, now finally we are on the coding part, and I'm going to use Kaggle because it provides us a lot of the data set directly, and it also provides a GPU. So if you are using the machine learning, or if you are going to use the deep learning models, then Kaggle will be much better option, because what happens, it provides you GPU for the 30 days and 30 hours, sorry, for every week, and also the TPU for the 20 hours. I will put this notebook link in the description also. If you want, you can check out it. Now first part, let's see how we start with that. So first of all, I have imported the polars as PL. Why polars? Because pandas also we can use for the data manipulation or the using the data, but polars is much faster than the pandas, because what it is built on the Rust, and it also provides the streaming of the data. So what happens, it does not load all the data into RAM at once, it can stream that data, so that makes it much faster, and as well as it can handle a lot of data, then that can actually be more than the RAM itself. So this is the one benefit of using the polars. And the syntax almost same, some syntax are different, but mostly are the same. Now next is we are going to import our matplotlib.pyplot as plt. Why matplotlib? It also if you have done some ML algorithms, then you will know that matplotlib is a visualization library that can be used to visualize the charts and all of that things. Okay. Now next is our loading the data. We need the data first of all. So for that I have loaded df equals to the what, pl, that is polars dot read csv. This is the function in the polar to read. It is also part of pandas also, pd, and read csv, and data will be kaggle slash input. This is the data I am going to use, that is student study hour. If you want this data, I will put the description also, and you can also use it directly in the kaggle also. How you will see here. Now I have already added here, but you can click on the add input, and here you will search the same thing, student study hour, this one thing, and when you search it here, then you will get hit this, and you can simply press the plus, and that will be you will see here this data, and simply you can copy this path and paste it in the here. So this is the location, that same location here I have put in here, so same will be there. Otherwise I will put the link of this notebook, this data set also, you can download and upload it here, so also you can use it as a upload also. Okay. Now next, Next is our pre-processing. So next step is pre-processing. For that, let's see how our data looks. So df, and let's run it. This is our data. This is ours, one column, and second one is scores. First one is string and second one is I means integer 64. So this is the string, but computer does not understand, or the algorithm does not understand the strings values, so we have to convert it to the normal numerical values. So first step is to convert it to the numerical values. So for that, what we will do, df equals to the df dot with columns. This is the Polar's way of doing working with the columns. So with columns, what we are going to do, polar dot column pl dot col, that is name of the column ours. So we have this is the name of the column ours. Dot cast means in which data type you want this column to be. So dot cast pl dot float 34. So we want it as a float 34 because these are the point values. So I have given it float and 32 is enough for the, because not in the depth points are, so 32 is enough. Now next is df equals to the df drop nulls. So why I am doing this, let's see why I am doing this. So for that, let's again print it, and what happens, let's see. Now these values are normal integer normal float values. It is now f32, but one problem is there. If you see here, there is values which are null, so we can't use it directly now. We should not use it directly, so null value should be if we want, we can fill it, otherwise it should be removed. And we know y means our target is also null, so no need to fill it. Let's remove it. So let's remove it. For that we can simply do df equals to the df dot drop nulls. What it does, it removes all the nulls from the rows and all the columns. And next, now main thing, we want x and the y. What is the x? X means our feature, that is r, that will be given there, and score, that value which we want to predict. So y will be our target and the x will be our feature. So x here and the y here. X capital and the y is lower. Yx is capital because it can be a multiple feature values. So here we have only one feature, but sometimes most times what happens, we are having the several features like R's and the environment. You can have the other values like his school, which tier school he studies, that can also affect the marks he will get, and other things also can influence the our target value. So for because of that, we have the lot of the features. So that's why we use at is matrix. It can be a matrix of the so many features. That's why we use the capital X. Mostly time we use capital because if we want to use it for the matrix. So for matrix name mostly are the capital. No worry to confuse about that. It is a common way to write. And next is what x is r's, df r's, that only column we are going to take, and to the numpy. Why numpy? Because numpy makes the thing calculations very faster, because it works the under the hood of low level language, or you can say lower level languages. So to numpy we are going to change it to numpy, from the polar to numpy. And next is reshape. Why reshaping? Because to make it clearly, like reshaping makes is like columnar data rather than the rows data. So let's see how we actually get the x and the y. Let's print it both of these, and then let's see what we are going. So first is array, and that's why we have given the -1 and the 1 shape. So that is this kind of data we need. because sometimes why it is array, make it array. Why array? Because when we are having the several features, then it can add here with the commas. Now this is the first, and this is the x, and then this is the y value. Now next is xy, we have gone right, and next is splitting. What is the splitting? For any ml, generally every ml algorithms, we use the split methods. What is this? It splits the whole data, the x and the y data, into two parts. One is training part, other one's to evaluate. What happens if we don't do that? Then what happens, we are going to use the same data for the evaluation and the same data for the training. So what happens, sometimes model get overfitted. Means, let's say it learns the same data again and again, and it also evaluate on that, so it shows the very good result. But we don't want, we want generalization. That means if some other values come outside the training data, then it should also predict that value correctly. So that's why we take the whole data and crop it 80% for the training and the 20% to evaluate how good our model is. So for that, xtrain 80% we are taking, that is length of the x in 2.8, and change it to integer, because it sometimes give the float value, and here we can't cut the float value using the float value. We need an integer, so we are converting it to integer. So this is the way we get the split of that xtrain y train and the xtest y test. Now let's plot it. I have written the here we have imported the pyplot. Now matplotlib using plt.scatter chart, we are going to create a scatter chart of the x train and the y train. So how training data looks like, let's see it. And label will be study hours and the score. So let's run it. Oh, sorry. So let's run it. And we are going to get this data. So this is the our training data, how it looks. This is our training data. Now next step is, we are having the training data. Next will be, let's go to down, sorry, let's go down. Now we are going to do the linear regression using the, first of all, library, that is scikit-learn, the famous library. So first of all, from the sklearn, that is scikit-learn, sklearn.linear model, import linear regression. If you are having the scikit-learn pip install, that if you are running the local, you have to install the scikit-learn. On the Kaggle it is already available. So from the sklearn linear regression, we have imported the linear regression. Next is sklearn matrix. Matrix is mean squared error, to evaluate when we will predict the test data, then we will evaluate using the mean squared error. We have already seen the what is the mean squared error. Now next is I have normally written here that predicting the y test using the linear regression of sklearn library. Now we are going to define the model. So model defining is model equals to the simple linear regression function. Next is training. So for training, model dot fit, we are going to write the fit function is to train a model, and what to fit it, fit to the x train and the y train. So simply it will get this data, and it will plot different lines and get the actual w and the b values, that weightages. It will try to get the weightages and plot a perfectly, try to be most perfect line. Now after that, next is predicting y test. Now we get our model trained here on this data. Now we are going to predict. So model dot predict, और किस पे करना है, then we are going to predict on the x test. Okay. Then next is plotting the values. Let's see what is our result. This is the most exciting part. How good was our result here? So for that, we have written plot the scatter plot and the same thing, and we are going to plot a line here. That plot, it plots a line on the basis of x test and the y predict, and color will be red, that's why R. And one more thing, mean squared error, and that prediction, what was the error of that prediction, how much distance will square distance was get when we predicted that value. So we want less and less losses. Let's see, when I'm running it, then let's see, this is the our actual prediction here. So it is start from here, and this is the line we have predicted. Here line is our prediction and pointers are our test data. So this data the model have never seen, we have not included this to the training, so we can say that this is our model is performing very well and generalizing also. Now next, this is the binary. I'm using only one column feature, and the second is target. If we are having the more features, then same will be there, the same steps will be there for the multiple classes or the features. Now next, our more important thing, in that we are going to create this linear regression from the scratch using only the numpy and the basic calculations only. So now this will teach you how actually this linear regression or the sklearn actually working. So this is manual implementation of linear regression. I will put this notebook in the comment section, so you can also watch that later. So first of all, we want n and the n features of the x string, that is n, or you can say number of sample. N is number of samples, how many rows of the data is there and how much features are there. The feature we know one, and the number of sample we can get from the shape. The shape gives the two things. Okay, now comes the hyperparameters. We have already talked about them. First is m, second is b, and third epoch, and fourth is lr. Okay, m, initially we can take anything randomly. So normally it is a convention, or you can say normally we take the zeros. So np dot zeros, what it does, it creates a array or the matrices of this this length of the feature. So so it creates a array or you can say zeros, with the zeros, matrix of the zeros with the length of the number of features. So how many features are there, in that length it will create a matrix or the array with the filled with the zero value. Now next is b equals to 0. Okay, now next is epoch. What is epoch? Epoch is nothing but that we were changing the every step. So that step, the same step we were repeating for making the line exact, so that steps are epochs. Now next is lr. Lr is nothing but a learning rate, we have already seen. So I have given the low learning rate because our data set is quite good in the size. So let's see. Now next is initial values. What is the initial value? Initial value means minimum loss. Minimum loss means I am just doing the thing is like this is the way of breaking the loop. This is what happens if you given the lakhs of epoch and the loss is not converging, like loss is not decreasing, even model get worse, even starting the like this and this. So we don't want that it goes to the minimum and then again start to increasing the loss. We don't want. So we want to cut when it goes to low and starts upside. Then we want cut the model and the cut cut the loop to don't increase the loss again. Okay. So for that I have given the minimum loss variable, that is none. Minimum loss, initially minimum loss will be nothing and patience will be 0. Okay, now what happens if one loop gets the higher loss, then what happens, minimum loss will be current loss will be higher than the lower than the minimum loss. Now what happens when it starts increasing? Then what happens? Minimum loss will be minimum loss will be lower. That means lower than the current loss. Then we don't want to increase it, so that's why we will increase the patience, and one by one, 1 2 3 4 5, and we will put 100, let's say 100. So if 100 times the same thing happening, then we cut the things, that we can conclude that it is continuously increasing that way. You will see in the code also. Let's see, don't be confused if nothing is if something goes out of the context, then no worry. Then y equals to the y dot rave, that is, let's say if some extra like shape is there, then it flattens the y को flatten कर देता है. That means if extra array is there, extra column is there, then it will remove that. Okay, basically basic thing. Then training loop, our training loop, basically this is the where the steps going to start. So for epoch, in the range of epochs, so number of epochs, then we are going to do is y predict. We are going to predict, first of all, we are going to predict with the random values. So these are the random initially here we have set it. So np numpy dot, we are going to do the dot product of that. Dot product, why? Because what happens if x is the matrix, because of that feature, some more features are there, then we have to do the matrix, because same thing for the all the features, and then we will sum that one. So this is the numpy dot matrix. Normal matrix multiplication is there, x into m, x dot m, then we are going to add the b. So basically what we are doing the all the features at the same time. And next is error. Error is nothing but, we have already seen it, y predict and the minus y. And next is y is, this y is actual y, and this is the predictive value. Now loss, we are going to loss. So this is the, what is this? This is the mean square error. We are calculating it. Now next step is to calculate the gradient. We have already seen these value, these formulas. That is, we have taken the derivative of this in the context of m. So 2 upon n into n dot, and we are x transpose. T means x transpose. So we are doing the matrix transpose to multiply with the errors. So we are going to get the error for the each the x values of the with the context of features. So basically we are using all the features here, and to get the right shape we are transposing the x, nothing but to get the actual to allow the matrix multiplication. This is the necessary thing here to transpose this. Then db, that is the equals to the 2 upon m, are the same thing. When we do the derivative of that, we will get the np dot sum and sum of the error. Now next, if we get the gradient, like which side loss is decreasing or like that, so we will can decrease that loss here. So we are decreasing the value of m or b. Initially we have initialized with the 0. Now we are changing the value of m and b. And now next is, if minimum loss is none initially, like first step is there, or minimum loss is greater than the loss, then what happens? Minimum loss increase. That means if it is a first time, then we will set the minimum loss equals to the current loss. Or if let's say it is increasing that way, it is increasing not increasing that way, so we can set the patient to the 0, because sometimes what happens, let's say it goes decrease, and sometimes slightly increase and then decreasing. So slight increase we will not count. If patients run to the 100 times, then continuously increasing, then we will cut. So if minimum loss is greater than the current loss, like loss is decreasing, then no issues there, minimum loss will be loss and the patients will be 0. Now we are again seeing the like again if some 100 times it goes up, then we will see only. Now if it does not happen like that, means loss is increasing continuously, then we will increase the patience value. If patience is greater than or equals to the 100, then model not improving and we will break the loop here. After this, if not, then if epochs and 1000, that means if 1000 epochs, every 1000 epoch it will print the loss, because if every time we will do now, so what happens, 10,000 or 1 lakh loop is there, then memory can be full. Now now these all steps will be happen every epoch, in the every epoch. So every epoch M and B will be modified and the weight model will learn the weight here. Now let's run it. Now this is our training data. What it says, name NP is not defined. Oh sorry, we have to define here. So import numpy as NP. Now it should work here. Let's run it. Yes, now this is the loop. How fast it is, so linear regression is very fast. Now next we get the these, now model run the weightages. Now we have to predict. So let's predict it. Y predict equals to the M into the X test. Now we are using the test data set, and let's plot it here. And now the mean square here, that same thing we have done with the scikit-learn also. Let's run it, and now this is our prediction here. The loss is 3.63 and scikit-learn was 6.65. So our model is slightly, very slightly is better than, you can say, scikit-learn or not. We should not say that, because what happens, scikit-learn can be hyper tuned. So we can say we are actually the reaching same points. So because the more data size is very less, data size is very small, that's why already same result is there. So that's how we have implemented the linear regression from the scratch also. So if any doubt is there, you can ask in the comment also, and in next videos we will try to go for in the deeper and with the much bigger data set. We will try and use other models also. If you like the video, you can subscribe the channel and watch this video.